This is a video for 2 TVWO. I'm going to discuss exercise T1 from the test yourself of chapter 8. Exercise T1A. It says, calculate the area of each of the triangles above. I've made a sketch of the triangle ABC. You don't have to do that, but if you want it, of course you can do it. I also wrote down the formula. Area of triangle ABC is base times corresponding height divided by 2. Don't forget to do divided by 2, or you can do times a half. That's the same. First you have to look for the base. The base is always the outside of a triangle, so it can either be AC, AB, or BC. So for example, if I'm going to take AB as a base, then I'm going to go along this side with my finger. I'm going to look for a 90-degree sign to check if there's a corresponding height. No, there's no corresponding height here. Then I'm going to look at another side, for example, AC. I'm going to go along the side with my finger and I'm going to look for a 90-degree sign. Yes, there's a 90-degree sign here. So I'm going to use this as a base and then DB as the corresponding height. Base is 10 plus 10, which is 20. Write down the calculation and then put it in brackets. So this is 20 times the corresponding height is 24. And then divided by 2. So this is 20 times 24, which is 480 divided by 2. So that means that the area of triangle ABC is 240. Sometimes they give you a unit and then of course it's centimeter squared or meter squared or whatever, but now they didn't give you a unit, so you don't have to write anything down here. This is the second triangle. You have to calculate the area of triangle DEF. You have to do base times height divided by 2. First I have to look for the base. For example, if DF is the base, then I have to look for a 90-degree sign. There is one here, so that means that this is the corresponding height. Sometimes that happens, that an outside is the corresponding height. It's possible with a right angle triangle. I don't know what this is, but I do know what this is. Maybe I can figure out what this length is. I can do it because it's a right angle triangle. And which theorem can I use with a right angle triangle? Pythagoras theorem. So I'm going to calculate this. Let me put a question mark there. Pythagoras theorem. And then I can use this as a base and this as the corresponding height. Okay, let's do that. So we have side square. And then the two sides that are connected to the 90-degree sign are DE and DF. The hypotenuse is EF. DE is 44, DF I don't know, and EF is 55. 44 squared. Let me use my calculator here. 44 squared is 1936. And then 55 squared is 3025. Okay, that minus each other is 1089, which means DF squared is 1089. So DF is the square root of that number. I fit it in my calculator and then it says 33. Exactly. So you don't have to use the waves. So DF is 33. So DF is 33 right now, and then I'm going to fit it in as a base times height, which is 44 divided by 2. You can also do this the other way around, because this can also be the base, and then this is the corresponding height. That's also okay. I need my calculator for this, and that's 726. This is the area of triangle DEF. And the last triangle is triangle PQR. And I'm going to calculate the area here. So again, base times height divided by 2, or you can do times a half. Now I have to look for a base. For example, if this is the base, PR, which is 25, that's given, there is a 90-degree sign here. So this can be the height. But do I know what TQ is, this height? I have no idea. Is it in a right angle triangle that I can maybe use Pythagoras theorem? Yes, it is. But I don't know this side. I do know that side, but I don't know this side. So I can't calculate TQ. And what about this triangle? No, I can't calculate TQ here. So it's not possible to take PR as a base. Let's go look at another one. For example, RQ. If I use that as a base, is there a corresponding height? I don't see a 90-degree sign here, so no. Maybe PQ. If I take that as a base, is there a 90-degree sign? No, but I can see that they extended the line here with dots. So, and there is a 90-degree sign here. So I can take SR as the corresponding height. I don't know what SR is, but it is a right angle triangle. And this number is given. So I can calculate RS. And once I know it, I can use it for the corresponding height. And then I'll take PQ as a base. So here we go. I'm going to calculate RS with Pythagoras theorem. I'm going to make a table. The two sides connected to the 90 degrees are QS and RS. The hypotenuse is RQ. QS is 8. RS we don't know. RQ is 17. 8 squared is 64. 17 squared is 289. And that minus each other is 225. So RS squared is 225. RS is the square root of 225. And we know that one, that's 15. So now I know that RS is 15. Let me write it down. It's 15. Now I can take PQ as a base, which is 12 times the corresponding height, which is 15, and then divided by 2. Let me tell you something here, because some people say that the base is all the way until here. So that's 12 plus 8. But this is actually the dotted line. So this is not included to the triangle. So this is all air. You can say it's just air. And then this is a triangle. So we only take the base what is corresponding to the triangle. So that's 12. 12 times 15 is, and then divided by 2 is 90. So the answer of the area of triangle PQR is 90. In exercise B, it says, in triangle DEF, choose side EF as the base and calculate the height DG. So now I'm going to go back to this triangle DEF. I already made some calculations here, and now I'm going to focus on this, because they want me to take EF as a base. So I'm going to write down the formula again, and as a base, I'm going to take EF. Okay, let's have a look what the corresponding height is. So when EF is the base, that's 55, by the way, I can fit it in later, then this is the corresponding height, so it's DG. Do I know what DG is? No, I have no idea. Can I figure it out with Pythagoras theorem? No, because this whole length is 55, and I don't know what this part is of 55 and this part. So I can't calculate what DG is. So how am I supposed to calculate the area then? Well, let me write down DG first. So this is DG divided by 2. Well, you already calculated the area. We already know what the area is. It's 726. So what you need to do here is you're going to fill in on the place of area. You're going to fill in 726. EF, we also know what it is 55 times DG divided by 2. Now, and this is something that you have to write down. And from here, you're going to do the balance method and you're going to figure out what DG is. Okay, I have to figure out what DG is, and I'm going to do that with the balance method. So you see divided by 2 over here, and I'm going to do the opposite. So I'm going to do times 2 on this side, times 2 on this side. And then it divided by 2 is gone. 726 times 2 is 1452. Let me just write down what I did here. So this is times 2. That's what I did to go from this step to this set. I did times 2 on this side and times 2 on this side. Now I'm going to do the opposite of times 55. That is divided by 55. So from this step to this step, I will do divided by 55. Now, 1452 divided by 55 is 26.4. So that means that DG is 26.4. In exercise T1C, it says, In triangle PQR, choose side PR as the base and calculate the height QT. Okay, now I have to take PR as the base. So PR is this side, which is 25, is the base. So I'm going to write that down here, PR. And now I have to do that times the corresponding height. There's a 90 degrees sign here, so TQ is the corresponding height, TQ divided by 2. Now, I already know what PR is, so I can fill that in. I don't know what TQ is, I have to calculate that. And divided by 2 is already here. Now, this is the part that I also know, because I just calculated it and it's 90. So I can also fill that in. Okay, so it's 90. PR is 25, TQ, I have no idea, and then divided by 2. A lot of students actually have problems with these kind of exercises, but what you have to take in mind is that you can calculate the area in another way. We just did that, is 90, and then they ask you to calculate another height or another length in the triangle, and then you can use the area that you already calculated to calculate another length. In this case, it's TQ. So it's really, really helpful that you can also fill in the area. Now, let's do this. It's balance method. First of all, I'm going to do times 2 on both sides. So that's 180. And then I'm going to do divided by 25 on both sides. And that's 7.2. So divided by 25 here, then it's gone, so you only have TQ. Divided by 25 here is 7.2. Exercise T1D says take QR as the base and draw the corresponding height PU. So I have to take QR as a base, which is this line, and I have to take PU as the corresponding height. There is no U here, but there is a P. So you know what, since there is no corresponding height, when I look at the base QR, I have to make it. So I'm going to extend line QR, and I'm going to do that with dotted lines. Okay, and then this line I'm going to check. I'm going to use this 90 degrees line over here, put it exactly on top of it, and then I'm going to slowly go to point P. There it is, and I'm going to make that corresponding height, which has a 90 degree sign here. So this is point U. Now this is the corresponding height that I want to calculate, so PU. That's what I'm going to do. Exercise T1E, it says, calculate the height PU. Round your answer to 1 decimal place. Okay, so here it is. Area triangle PQR is base times height divided by 2. I had to take QR as the base, that's what it says in the exercise, and then I just drew the corresponding height, which is PU, so it's PU divided by 2. Now, again, I already know the area, I already calculated it. In the first exercise that I did was 90, so I'm going to fill in, it's 90. QR, I already know it's given. You can't see it here, but you can see it in the picture in your book. It's 17. And PU I want to calculate. So this is what it looks like, and now I'm going to do the balance method. So first times 2 on both sides, times 2. So then this will be 180, 17 times PU. Then I'm going to do divide by 17 on both sides. And in the exercise it says that you have to round off to 1 decimal place. This is 10.58888 and so on. And then a couple of other numbers. So let me round it off. It's PU rounded off is 10.6. This is also waves. So this corresponding height, PU, is 10.6. This was the explanation video of T1 of chapter 8. I hope you liked it. Thanks for watching.